this time, I need everybody's full attention. Yeah, this class is going to you need to put your focus on for the next 6 weeks straight. So you'll get your 10 minutes bell work, and then we gotta go. So I'm gonna go ahead and answer these real quick just to make sure you've got the idea. It seemed like most students did get the correct answer here. Everybody should have gotten the correct answer, as this was on your quarterly, which was given back to you, both of these questions. So a primary alcohol is one in which you've got a carbon that's only connected to one other carbon. You've only got one of those here. Only one. So one primary. A secondary alcohol is when you've got a carbon with the OH that's connected directly to two other carbons. And so this is 1, this is 2, this is 3, and this is 4. You've got 4 of them that have a carbon directly connected to 2 other carbons. If I put this line here, what would that have become?
A tertiary.
Tertiary instead, but that's not there. And so a lot of students actually didn't get this correct on the quarterly exam. This is something you will need to go back and review. So I just wanted to go back and review it with you because it is going to become important as we get later on into the lessons in this unit. This question, the systematic name of D, start numbering at your functional group. 3-methyl bute 1E. You must label where the double bond is if there's an option of where it can go. It could either be on carbon 1 or it could be on carbon 2. So that's why. And then the other one is just moving this double bond one more time. Here it's here, here it's here, and then so the other one would be moving it there. Like here, here, or there at the end. And position isomer changes the position of the functional group. So this would be the positional isomer for both C and D would be this one here. And so it's about, we're going to go over some schedule stuff. We are starting unit 6. We will be here almost until spring break. This is a hefty unit of study. It will have 2 exams. And I'm going to explain how you're going to have those 2. Well, let me start with about 40% of your Cambridge exam can be organic chemistry. 40. Nearly half. Meaning, out of all the units of study, the other ones you might get by, like, if you're like, oh, I hate that unit, whatever. I'm not going to do it. I'm going to skip that test. You might get by. This one, you won't get by. You have to know some organic chemistry. And my goal as an instructor is to prepare you the best way I can in order for you to be successful in this topic. So I'm going to tell you how you're going to do that. And for those of you who are taking ACE Math, I do apologize because it is about to get stressful for you. So do your mental exercises, get a stress ball, do whatever it is you need to do, because I'm going to tell you very shortly what it is we have to do. So first of all, I'm going to go back to the objectives after I go over your memorization checklist and your schedule and your mini assessments. So first of all, memorization checklist. Go back this week and make sure you know the following from Organic Part 1 because they're linked. Do you know your prefixes of your organic names? That's meth, eth, prop, bute, pent, and hex specifically are the main ones you need, 1 through 6. Monkeys eat peeled bananas, and then pent and hex. You know that, put a check mark. Put a check mark on the things you feel good about, and put a question mark on that which you need to go back and review. And you should do that this week before it gets more intense. Suffixes of organic names and functional groups. If you got a ketone, do you know that that ends with -one? If you got an alkene, you know that ends with -ene? If you've got an ester, you know that ends with -il and -oate? You know all that by heart? Put a check mark. You don't all know that by heart? Put a question mark. And go back and review. Primary, secondary, tertiary carbons. If you felt good about that in the bell work, put a check mark. If you didn't feel good about that in the bell work, put a question mark. I'll see you at tutoring. Difference between displayed structural and molecular formula. Do you know how to do all your different types and also skeletal? Like how to draw them all out. If you're asked for any of the types, you could do it. Put a check mark if you feel comfortable with that and a question mark if you know you need to go back and review. Because again, these 2 topics are linked to each other. Functional groups, names, and structures. It is essential. You must know all your functional groups by heart. Because what we're going to be looking at is reactions by functional group starting today. So if you don't know what functional group you're looking at, you're going to have no idea how it reacts. So functional group, names and structures by heart. If I give you this, you need to know that this is what? What's that? And like in 5 seconds, you need to know that's a carboxylic acid. And carboxylic acids and esters react completely differently from each other. So if you don't know which one you're looking at, you're going to be lost in the applesauce. Memorize your functional groups. Next one. Isomers questions will be showing up in your homework randomly and possibly on your Unit 2 exam, because when you see organic, you see it all together. So you're going to have to review back over your types of isomers, including stereoisomers. Finally, this is what we're going to be spending the bulk of our time period over the next 6 weeks going over, which are the major types of organic reactions. And so remember, and some of you didn't take pre-A's, but if you did take pre-A's with me, we went over 5 classic chemical reactions. And if you recall, you had situations where you had to know, for example, if you saw this, you would have to predict the product. Do you remember that? So first you would have to identify what type of reaction you were looking at. You would need to know that this is synthesis. And then you would have to know the structure. A plus B goes to AB. And then put them together properly. And so you would get the MgO and balance the equation and all that good stuff. That was a preview of what this unit is. You are going to have, just to shout out a number, about 25 different reactions to study, which is about a quarter of a regular organic chemistry class in a university. So guess what you're going to get starting next class? Flashcards. I bought them. I would have had them for you today, but I left them at home. It was too early when I left. I have them in a box in my house. But you will be getting a set of flashcards. Starting next class, I'm going to teach you how to make your flashcards today. I went and I made slides on it. And then starting next class, while we're in class, you're going to be developing your flashcards. I even bought them with a little ring binder. So you'll have them all together on one ring. That'll be a project grade for this quarter for you to study your organic reactions. Welcome back. Janie, you're next. Or sorry, Mariana, you're next. So, here's our schedule. We have a tight schedule for the next 6 weeks. This looks overwhelming. I'm just going to shout out a couple of important things. First thing I'm going to point out, this Friday, you're going to see this thing called a mini assessment. You're going to want to highlight each day you have a mini assessment. That means in the last 15 minutes of class, you are going to have a mini assessment. It's the best way I can call it. I'm going to explain what that is in a little bit. And it's going to be based off of what you did in prior class periods, not including that day that we learned. For example, the one on Friday will be today's lesson and Wednesday's lesson, but won't include Friday's lesson in the mini assessment. Talk more about that in a little bit, but you want to highlight those days that have mini assessments on the schedule. The next thing I want to bring up is on the 1st. I'm trying to be as accommodating as possible, and there are a set of students that will be out on college tour that day. So I've worked the schedule as best I can. I've, Tetrised it as best I can to make no mini assessment that day and no new lesson that day. But just for those of us who are here, we will practice and practice and practice. Make sense? So it's kind of like a stop. We did all these weeks of material. Let's stop and just practice this, and then we'll continue on. So far, so good? There's one day I won't be here, so you can point that out. But I have pre-recorded the lesson for you, and I did this last year as well. That means your lesson one of these days will be on Edpuzzle. I won't be here, but you'll still be doing it, and we'll review when I come back. And I'll actually have a printout with like the notes for you the class period before. That day that I'll be out is the 22nd. So Bleed's not here. Bleed not here. That doesn't mean you're not learning. That just means you're learning on your own time. Because I'm posting it on Edpuzzle. You still are responsible for that lesson. You'll have to show me your notes next class. And I will give some time to review the class period after. And then I won't give a mini assessment until the week after, if that makes sense. Just to be as fair as possible. There won't be a mini assessment that week that I'm out on a Tuesday. That's that 3-day weekend that we have President's Day. So that'll be a little bit of a brief reprieve there for mini assessments. And then I think that's all the major things I need to highlight. I painstakingly went over the schedule to make sure that every single topic that has to get covered gets covered. So starting today, we're going to do reactions of alkanes. And we're also going to learn something called free radical substitution, what a mechanism is. Next class, we're going to do another type of reaction. I'll be distributing your flashcards, and you'll be starting to make those flashcards. Those flashcards will be your project grade for unit 3, or for quarter 3. They will be your project grade, and there's no exemptions on those. You got to do them. They're to help you practice. Now let's talk more about those mini assessments. What's that? So I did this last year, and I'm changing it up a little bit because I want you to be as prepared as possible, and I don't want you to cram before this test because I know there's a lot of information on this test. So each mini assessment is going to take place at the end of the class period starting Friday, meaning it's going to take place between 2:05 and 2:20. It's going to have 10 questions. Straight up, 10 questions each one. And they're going to be on paper. They're not going to be multiple choice. Mini assessments will start on Friday. They're going to include all content up until the class period before the assessment is given. So that means that for Fridays, it's going to test what I teach you on Monday and Wednesday, but won't include Friday because that's not fair. You'll have time to study for Monday and Wednesday. And so each mini assessment will be cumulative unless otherwise noted, meaning that as we go through, it'll get harder because you've got to know all the reactions up into including wherever we get to. So that means try to do as well as you can on the first few, right? There will be a total of 9 via the schedule that I posted to you. The lowest 3 scores will be dropped. So you do awful on 1, it's not the end of the world. You miss a day of school, it's not the end of the world. I'm giving you 33% like that you can either completely mess up on or just not show up for. So far, so good? So your top 6 will be your average exam grade. And so the top 6 mini assessments are going to go in once all 9 have been given as a unit exam grade in the grade book to go with your unit 5 and your actual unit 6 exam, which are all the Cambridge questions. And finally, any student who averages an 80% or higher on all 9 will earn a public sub during lunch on the class period before we go to the break, the spring break that we have. So that's a mini assessment. I'm going to teach you what the questions look like on a mini assessment beforehand, of course. I did this last year with the AS chemistry group, and I did find that it increased their fluency in organic reactions. Like they ended up doing better because of it. And so it's something that I feel really strongly about that we do as practice. You do have opportunity to practice. I'm moving tutoring this week to Thursday in case you want to practice for the first mini assessment. Tutoring this week is going to be Thursday instead of Tuesday because the first mini assessment will be Friday. And then next week tutoring will be at the regular time on Tuesday. Welcome back. Sophia, you're next. All right, so far are we clear on the schedule? We know what we're going to have to be doing? We're mentally preparing ourselves? Ready to make your flashcards on Wednesday? So here we go. Unit 6, Lesson 1. Today we're going to learn about the reactions of alkanes. As we go through each lesson, we're going to go through each functional group and what we're doing for each functional group. So the first functional group are alkanes. Before we move on, what are alkanes? What's this? Saturated hydrocarbon, right? Yes. Alkanes are nonpolar, right? And traditionally and famously unreactive. Funny. So my lesson today to teach you is about alkane reactions, which means if they do react, how do they react? There's literally only two things that can happen to them. Only two things. And we're going to talk about what those two things are. So, two types reactions only. And you're going to need to know both of them. One of them you already know, and the other one I'm going to teach you today. Yes?
February 24th is a Saturday.
Then that is the 20. Are you sure?
Yeah.
Then it's the 20th and 22nd. Then it's the 20th and 22nd. I'm just talking the days here. It's that week though. The 20th is the day I'm out. The 22nd would be the day that we do that next lesson. I'm out the Tuesday. I'll be there the Thursday. All right. So snooze fest. What do we have to do here? Objectives. It says learners, and you'll see that I took out stuff we already done. If something's missing, it means I already covered it with you, or it's not in today's lesson. Today, we actually already did this. The complete and incomplete combustions of alkanes. Did we do that already?
Yeah.
Complete makes CO2. Incomplete makes
CO.
CO. We've already done that. We're not revisiting that today, except maybe it'll show up in an example in your homework, just because these questions are usually put together. This is new. The free radical substitution. I mentioned to you what free radicals were back like a long time ago. I mentioned what they were, but I said we weren't going to revisit them until much later in the year. We are now much later in the year. Free radicals. We're getting to free radicals today. And with reference to the three steps of initiation, propagation, and termination. So today you're going to learn something called a reaction mechanism, which is the story of how the bonds are broken and the new bonds are formed. So you're going to learn the story of the chemical reaction. And I'm going to tell it like it's a story as we do each one. And you're going to have to memorize these stories. And they're called reaction mechanisms. How does this happen? Finally, the last one here is understand that alkanes are unreactive. And there are two reasons why. The first is because they're nonpolar, which you all shouted out right at the beginning. We know that they're nonpolar. The other you're now prepared to listen to is that they have strong CH bonds. What is that? Strong CH bonds. I might have to go back a second. Strong bonds. What does that mean? Nah, that's not a hydrogen bond. That's part of its, let's go into our data booklet. 9701 data booklet. If you ever need the data booklet, that's what you type. 9701 data booklet. Our syllabus number is 9701. Let's go to the data booklet real quick. Last unit, we talked about something called bond energy. So what I'm going to pull up now is the bond energy. So for the CH bond energy is 410. That means it takes 410 kilojoules to break that bond. That's what they call a strong bond, because what you're going to compare that to is the CL-CL bond, or the BR-BR bond over here. And those are 242, 193, and 151 for your halogens. So this means these require less energy to break their bonds than to break the CH bond. So what do we mean here by strong bonds? We mean requires a decent amount of energy to break this bond. So if we put into effect that, first of all, this molecule is nonpolar, non-polar molecules, they don't even mix with polar molecules because remember, like dissolves like. So if we have a non-polar molecule, it isn't going to react with anything that's polar, and it takes a lot of energy to break down their bonds, to break them apart. And so what we're going to see here is we can only do two things with alkanes. Two things only. So here we go. I already went through this. I already went through this. You can track along as we go through each day. Beth had brought up this should be the 20th. Thank you, Beth. And this should be the 22nd. It's that week, though. Same week. If you want to fix that in your calendar. The 20th is the day I'm out. I'm actually teaching on the 15th and getting on a plane when I guess. I'll be here for this class, and then I'm leaving, and I'll be back. I'm going to Super Nintendo Land. You know where that is? Los Angeles.
Bring back a coin.
Maybe for the classroom, right?
When are they going to bring it to Florida?
2025. 2025?
We graduate. No. Wait, no, that's next year.
Wait, what year do you graduate?
Next year.
So I think it opens right after you graduate, like after grad bash probably. All right, here
We
we go.
could have the gold coin and say, this is AU.
Oh yeah, I'll put it on the classroom. All right, here we go. So, reactions of alkanes. I've already said all this, but you should note that alkanes are generally not reactive. They tend to be very stable. And this is mainly explained through electronegativity. You do not have to memorize electronegativity values, but what you should know is that the electronegativity difference between carbon and hydrogen is 0.4, which falls into the non-polar range. And because that falls into the non-polar range, no matter how small or how large your alkane is, it's still non-polar. So I can give you some crazy thing like this. It's not that crazy because I ran out of space. I guess I should probably do skeletal if I want to go really crazy. I can give you something like this. And it's still non-polar, right? Still not going to react. Still only does two things. No matter how large, no matter how small it is. And so non-polar molecules do tend to be stable. They can't be attacked. And that is the terminology. They can't be attacked by nucleophiles or electrophiles. I'm just going to put some eyes there. We'll learn what that is next class. That's coming next class. But alkanes can't be attacked by what we call nucleophiles or electrophiles. But apparently they can be radicalized, which we'll learn today.
That sounds like terrible.
They can't be attacked by nucleophiles or electrophiles. We'll learn about what those are next class. So, here we go. There are only two things alkanes can do. Literally two. Number one, you can burn them. You can burn alkanes like propane, butane, octane. These are fuels. You can burn them. So you provide some oxygen. Where's all that? You provide some oxygen, you provide some spark, and you burn them, right? So burn, fire, right? You need to know what combustion reactions look like and how to complete them. Yes. I'll go ahead. The second thing you can do is you can do something called a substitution. This is new. You can only do this with halogens in sunlight. And this is what we call a free radical reaction. So I had actually taught you about the 5 major classifications of reactions when we did organic part 1. What a substitution is, and you'll see here this is methane. What does substitution mean? Sub. Sub something out. By the way, we're learning subs and you can earn subs. Random fun fact. What does a substitution mean? Replace, right? Replace a hydrogen with a chlorine. Literally a double replacement reaction from the past, right? because these two go together and those go together, and you get the inners and the outers. Literally looks like a double replacement. Because a lot of these organic reactions also do fall into the 5 categories. It's just they might look a little different. Because organic chemists are built differently. It's my first reason. Everything gets a new name in organic chemistry. All right, so we're going to learn why this is called a free radical reaction shortly. But let's talk about what happens. First of all, this reaction cannot take place in the dark. If you have methane in this classroom, you don't have UV lights, you have a lab, you don't have a source of UV lights, that reaction ain't happening. It's just going to chill because alkanes are unreactive. You need sunlight as a condition for this reaction. And so the mechanism for the process, which will also be the full name, is called free radical substitution because it involves the use of free radicals. So once again, the essential condition for this reaction to take place is sunlight. It won't happen on its own. So this happens at the upper layers of the atmosphere, generally speaking, and is part of how the ozone layer was initially depleted. They've been repleting it over the past 30 years, but due to this type of reaction, the free radical reaction. Environmental. So I would have had your flashcards today, but like I said, at 6:15 a.m. I got here and I was like, "There's no flashcards." So I will have them for you next class, but I'm still going to show you, and I printed this out for you, on how you're going to make your flashcards, and then during next class bell work, you'll make the flashcards for this first reaction because we're only going over one type today. So how are you going to make your flashcards for the Unit 3 project? Flashcards, Quarter 3 project. The front of your flashcard, I would like you to make 3 flashcards for each type of reaction. 3 of them. The first one would be the type of reaction on the front, the type / name of reaction. You may want to fill this in. That's what I'm looking for each flashcard. And you see I did friends. And then the back would be, well, what happens here? What is the recipe, right? The full equation for the reaction. So what is the full equation for this free radical substitution? You start with any alkane. You add a halogen. Halogen X2, what does that mean? Standard state. Standard state. You add some UV light or sunlight. You can say either. And you get an alkyl halide. What's that? Alkyl halide. Alkane with a halogen. And then this is what we would call a byproduct. So this is the organic product. And this is a byproduct, HX. So it could be HCl.
One of the hydrogens get replaced by a halogen.
Yes. So hydrogen swaps out with halogen in a free radical substitution. You could think of it like that. Hydrogen switches with halogen. And this can happen more than once. And when I teach you the mechanism, I'll teach you why that's so. This can happen more than once. But this is your first flashcard. So when are you going to make your first flashcard? Next class during the bell work. So you're not going to lose this paper. You're going to remember how to do these. Next class is bell work, I'll remind you. And in the future classes, I'm actually going to set aside time. Like at this point, I would say stop and make this flashcard so that you don't have to go home and do it. You could do it during class. That's the goal. And then what are you doing when you're at home? You're reviewing your flashcards. Or in other classes when you have times or brain breaks. Second flashcard. You should make a flashcard of the conditions. Does that mean that Cambridge wants you to memorize conditions?
Yes.
They do. They could literally ask you, what's the condition? Second flashcard. For free radical substitution, the condition you need to memorize is UV light. So that will go on the back. Front is conditions for this type of reaction. Back is just UV light. For whatever type of reaction, you need to memorize the conditions. Finally, I want you to make a third flashcard with what we call an example reaction. With just the reactant and the conditions. And leave the products blank. Why? Because on the back, and you're quizzing yourself. This is how I studied organic chemistry. I always quizzed myself. I had like a pile of flashcards that deep, and then I would just put the ones to the side that I knew and redo the ones that I didn't know over and over and over again until the pile went away. That's how I would study organic chemistry. So your third flashcard will be your reactants for an example equation, your conditions, and then you complete the reaction. And so you notice here that I have the completed version of the reaction on the back. So once again, for every type of reaction, you will want 3 flashcards. One with the main name of the type and what happens, one for the conditions, and one with an example reaction where you have just the reactants and conditions in the front and the products in the back. That's what you're going to need to make. Start working on it next class. Understand how to make flashcards? What's being asked of you? All right, cool. I'll ask you to take this out during bell work next class to make your first 3. So here we go. Mechanism. How does this happen? And before we do how does this happen, let's just go over what happens again. We said it was substitution, right? So I'm gonna put in a random new slide and see if you can try a couple reactions. If I gave you this plus this and UV light, tell me what the products are. See if you can figure it out. This is how your quiz will look, or your mini assessment. But you have 10 questions. So what will you do? You could do it like that. That is iodine. There's iodine. What is this? C3?
Yeah.
Where? You created things that don't exist.
No.
Pick any one of the hydrogens your choice, right? And replace it with I. So instead of this hydrogen here, I would replace it with I. Does it matter which hydrogen I choose? No. So where does that hydrogen go? To where? The other I. So the other one is high, right? Or you could have said C2H5I plus high, right? Or if you're really spicy, you could do this. Any format, unless you're asked for a specific type. I would usually do whatever they present to me. Like if I'm given displayed, I would end with displayed. That's how I would do it from Cambridge. If Cambridge gave me displayed, I would just go carry through whatever they gave me. Try another one. What about this? UV light. Wow, my UV light is not enough. UV light. What would you do? Are there multiple possibilities for what you could make? Isomers too, yes. What if I said give 2 potential products? What would they be? Okay, HCl though, because you know, CLH is not really the way we would write that. That's a byproduct. What's the organic product? You do this.
Yeah.
And or you could do this as your 2 options. Are we good with that? Hydrogen swaps with a halogen. You can choose for now what method you want to use, displayed or structural or skeletal. While we're learning, I do advise displayed you can understand the exact bonds being broken and the exact bonds being formed, which is what I'm about to teach you with the mechanism. Because octet rule is still a thing for organic chemistry, for these types of reactions. All right, do you get the idea? So on Friday, quiz is going to be 10 questions off of the reaction today and the reactions on Wednesday. And you're going to be given reactants and you're going to have to figure out products. Or you're going to be given reactants and products and you have to figure out conditions for the missing reagent. That's what the quiz is, just so you know, as we're moving forward. So let's talk about mechanisms. So the mechanisms are the story of how the reaction happens. Bet you never thought you'd hear stories in chemistry. It's how did we get here? What exact bonds were broken? What exact bonds were formed in order to go from reactants to products? In order to be able to go over how to get from reactants to products, you're going to have to learn two types of bond breaking bonds. There are two ways in which chemical bonds can break. Today we're going to go over homolytic. Need to be taken. And next class we're going to be going over heterolytic more. Homolytic. Underline the prefixes. Homo versus hetero. These always mean something, these prefixes. Homolytic fission typically takes place between two of the same type of element, but not always. What actually homolytic fission means is the following. Let's say you had chlorine and we had another chlorine. First of all, what's fission? I haven't heard that word in a minute, right? Fission. Splitting. When we did nuclear chemistry, which we haven't looked at since the first unit of pre, we learned about nuclear fusion and nuclear fission. But fission itself means to split apart. It means to break, right? To split apart, to break. And so what happens in a homolytic fission is when this covalent bond breaks between these two chlorines. Would you agree that neither chlorine is more powerful than the other? They have the same power, right? So would both of the electrons go to one of the chlorines when that bond breaks, or would one go to each? One goes to each. And so that's what a homolytic fission is. And we do it with a little half arrow. That literally is a half arrow. Like it's half of an arrow. This is a half arrow. This is a full arrow. Cambridge wants a half arrow. For homolytic. Half arrow. Homolytic. Full arrow will exclusively be used for heterolytic. The other thing is that you gotta curl your arrows. Yeah, like it's gotta have a curve. Like that. Notice how I curved it? It's a curly arrow with a hook. So this is what we call a curved arrow. Curly arrow. Curly arrow. For mechanisms, you must use curly arrows. That's a Cambridge requirement. Curly arrow. What's the difference? Half arrow means one electron. Full arrow means both. So this means one electron. This means two electrons are moving. That's the terminology. You should write that down because that's important as we move forward. Establishing ideas, as we're going to learn the first mechanism today. So homolytic fission means bond breaks. Each atom gets one electron. In a heterolytic fission, which we're not going to see today, but I want to bring it up because you're going to see it next class. Let's say that you had HF. would you say one of these atoms is more electronegative than the other? So would one of them like want the electrons? So like, fluorine gonna be like, you ain't getting one back. Mine. Right? So this would end up becoming H ain't got any, and fluorine got all 8. This would be -1, and this would be +1. Does that make sense? This is what we call heterolytic fission. Any bond breaking we've ever done has been heterolytic. There is literally only one example of homolytic fission, and we're seeing it today. It's the first one we're going to do. It's the only time we're going to see homolytic fission, and we're never going to see it again. Like the rest of the unit, it's not going to be in any of the other mechanisms. It's a very unique reaction. Because alkanes, remember, are boring. You've got to force them to do something because they don't want to. Welcome back. So you can set them on fire. They'll do something. Or you can experience them to free radicals. Here we go. Are we good? We're good to move on? All right. So this is, again, what this looks like. But there's a key here. The result of a homolytic fission is a free radical. In the example I've shown you, which is the example up here, when this bond breaks between these two chlorines and the half arrow goes back to each one, what does this mean you make? At the end, a chlorine like this and a chlorine like this. Do you think that's stable? That is not chlorine in its standard state. Go ahead. That's not in its standard state. Do you agree? This is a radical. Meaning it is a chlorine. This is a chlorine that has 7 electrons, not 8. And yet it's existing. So if something is a radical, do you think it would be reactive? Yes. And so radicals are very reactive. Like this. Very reactive. So goes back to each. You get free radicals. We are radicalizing elements. Once you have a free radical, that free radical can radicalize others. And it's interesting because this actually has other applications. Because free radicals can be used in politics, right?
Wait.
Radicals radicalize others.
Are there any
Right?
Yeah, like CMP.
Go ahead. Are they what? Super dangerous. So let's talk about the story.
I'm sorry, you can't hear.
Ready for the story? The story. Free radical reactions. This substitution will take place in 3 steps. You have to memorize these steps. I'm going to teach you these steps as a story. So the question is, how did we get from here to here, right? How did we make this thing that does not want to do anything become something polar? How did we polarize this? How did we make that happen when it doesn't want to react?
We move it to
So-
polar.
So the story. And you're going to have to rehearse this step by step. And there's going to be 5 different stories in this class. In the next 10 weeks, we go over. This is the first of 5. We're going to learn 2 of them this week. The first step is initiation. In the initiation step, you form a free radical. An initiation. If I've ever heard one. You form a free radical in your initiation step. And that is the name of the step. If you have a free radical reaction, Cambridge will ask you what are the steps, and there'll be a point for each step. So initiation is the first step. We form our free radical, our unstable atom. Then, step 2, you propagate, meaning that your free radical will attack the reactant molecules, okay? So anything it can radicalize, it will radicalize. And this can happen over and over and over again. There can be millions and billions of propagations. And this is happening, you know, up in the upper layers of the atmosphere sometimes. Yes. What? Free radical reactions? Free radicals exist in your body too, and that's called cancer. Right?
That's why they spread.
That's how they spread so.
Oh, it is how they. No. That's nice.
So radical.
It is all.
I mean,
How do you form the free radical?
we're about to go over it. So, propagation means free radical causes other free radicals to start to exist. It spreads. Until you get something called a termination. The end. In termination, 2 free radicals actually meet each other. They hook up. They make a molecule, and there are no more free radicals. They become stable.
The propagation. Oh, that's not gonna solve your.
So we're gonna go over how this happens. Ready? So these are the names. We're gonna show how this occurs. Go ahead, Hakeem.
So what I got from this is join a cult, become mentally insane, and once
Someone
you
else?
meet someone equally mentally insane, you will finally be able to settle down.
But that's what happens with molecules. All right, here we go. So here's an example. I'm going to teach you one from scratch, but you can see what it looks like. I want to bring something up here. In your initiation step, first step is the weakest. I'm laughing because the weakest bond breaks.
Oh.
The weak breaks first. So. The weak breaks first. Ready? Okay. The weak breaks first. If you've got all right, go back to the beginning of this reaction. So, we've got methane. We've got chlorine. We have exposed methane and chlorine to UV light. So far, so good? UV light will break one of those bonds. Which one will it break? The chlorine. Why? Go back to your bond energies. If you go back to your bond energies, but you don't need to memorize them, but it's explaining why. The weakest breaks, right? What is the bond energy of chlorine? I believe it was 242. This is 410. So what's the weak? The weak breaks first. So the halogen always breaks first. And you do have to remember that. The halogen bond breaks first because it is actually a weaker bond. And you can consult your bond energy values to figure that out. You have those numbers. This is 410, this is 242. This is weaker bond, it breaks first. The chlorine-chlorine bond will break first. I'm gonna head back here just to show you. You have these numbers. 242. Notice the trend here, by the way. They do get lower, except the chlorine. I like trying to betrayal. But typically, the larger they are, the farther they are, the weaker the bond. And so that's the idea. 242 is weaker than, if we go to CH, you know that's recording, right? Totally heard that. 410. 410 is much stronger than 242. All right, so does it make sense? The halogen always breaks first. We're good with that? Halogen breaks first. It is always the halogen that breaks first because no matter what halogen you have, it's less than a CH bond. So you radicalize your halogen. Then, and this is why you may want to write out your steps each time. What's happening? This bond breaks, but it's homolytic, meaning that each chlorine gets how many electrons? At the end, it'll have 7, but each gets 1 from the bond. So you get this chlorine with 7 electrons and another chlorine with 7 electrons. I want to point out something. For our benefit, you may want to write all 7. Cambridge don't care. They write free radicals as a single dot. They're like, unpaired electron, you get the rest.
What if there's more than one?
Unpaired electron? Yeah. Propagation. Ready for the next step? All right, so now, chlorine has been radicalized. Chlorine has been radicalized and seeks to radicalize others. And so chlorine is fiending for a friend. And you've got methane over here. You agree? You've got methane minding its own business. And chlorine's like, hey, come with me. Come with me. And what can chlorine grab? Can chlorine grab the carbon?
No.
No, chlorine has to grab the. And the only way it can do this is if hydrogen joins it. So this bond breaks now that this free radical is available, and chlorine radicalizes hydrogen. And so now hydrogen is together with chlorine, and you've got a new radical. And that's what's being described to you here. You've now got CHHH that, and the H goes together with the Cl. Does that step make sense?
Yeah.
So you start by radicalizing chlorine. We call that initiation, the halogen. Then the halogen steals a hydrogen. That's what happens. In this, because it's a homolytic bond break, the hydrogen takes its 1 electron with it, and the carbon takes its 1 electron back. And so now you've got free radical CH3. And the HCl's together. And that's propagation. Propagation can continue over and over and over again. Meaning, you could keep swapping out hydrogens for more chlorines over and over and over again. So this would not be a good method. One of the things you'll learn throughout this unit is we can make different molecules that, and this is something that if you want to be a pharmacist or you want to be in medicinal chemistry, you would need to know different molecules you can make that are the starting for different medicines and drugs. And so this would not be a good method of making CH3Cl because you can make a variety of products here because it keeps happening over and over again because it just keeps spreading, right? So just so you're aware. Finally, what is termination? Step 3. Free radical meets another free radical. And so you've got CH3. If it happens to meet up with another free radical, it doesn't have to be chlorine, it can be any free radical. These 2 free radicals have electrons, and this chlorine's like, hey, I really want to be in with the gas. Like, well, how can we do that? We could just bond together in a regular covalent bond, right? And so you would make your product of CH3, Cl, which is what you see. These all just get together to form a molecule. Does that make sense? Are we good with that? That's the general process. You have to memorize this process. Initiation, propagation, and termination. So obviously going over it once is not going to be good enough. We're going to go over it again with another example, and then you're going to see some Cambridge questions. So, ethane to bromoethane. Free radical substitution of ethane to bromoethane. First of all, what's the overall reaction? Let's start there. C2H6. What would be the way that you would want to write this? Would you want to do displayed, or are you okay with doing molecular formula? You want to try molecular formula? Okay. So if we do molecular formula, we would get C2H6 plus Br2. And what is the condition? You must have UV light or it doesn't happen. Which means there can be the option for no reaction. I don't know, those of you remember that no reaction can be an option. No reaction can be an option. And no reaction can be an option on the quiz, on the mini assessments. Sometimes. Ready to continue? So what actually happens here? A bromine will swap out with a hydrogen. That's what it's called. It's called a substitution, right? So you would get C2
H5Br
H5Br
plus HBr.
plus HBr. That's the overall reaction. Now I want the story. I want the mechanism. How does this happen? Then I'm going to tell you how many marks this is worth. No, more than that.
Oh, you
Three.
can.
Somewhere between 3 and 5, depending on how much they ask. Mechanisms, when they show up, they typically show up, is the way to say it. They show up as a decent component on a paper too of the organic chemistry section. One of the 5 mechanisms you're going to study will likely show up. Last year, it was actually this one. This was not this exact example, but this type was the one that showed up last year. All right, mechanism. What is step 1? We have to write our step 1, and you should name it. Step 1. Simply put, you write the word initiation. That's good. Initiation. What are we initiating?
The breaking of the bond of
We are breaking the bond of the
Br.
halogen, right? So, what does Cambridge need you to show?
Br2 turn into Br with free
Do you have to write all the valence electrons?
No.
You do not. But you have to show the covalent bond. You have to show the bond breaking, how it's breaking, and then you show the product. So homo means 1, 2, each half arrows, right? 1, 2, each half arrows. So what's your product here?
Br.
Do you have to write Br plus Br? Is there another way we could write that? Like that?
Yeah.
That's totally fine. That's how it would probably be presented to you by Cambridge. Instead of Br plus Br. Like, you do you. You do whatever you want. All right, we're good with step 1? Step 2. Next part of the story. Propagation. And you have to know it by name.
Feels.
Propagation means your free radicals on the hunt to radicalize more. What is your free radical on the hunt? Bromine. You don't have to write 2, you just write 1 of them. There's many of them, because remember, this doesn't happen single. When you have molecules, there's millions. Think about moles. 6.02 times 10 to the 23rd. You got this.
Oh, you're
Right?
right.
How many dollars is a mole of cents?
A mole of what?
How many dollars is a mole of cents?
Figure that out. You just divide by 100. That many dollars. 6.02 times 10 to the $21. I don't know that. Probably more money than what's on Earth, I would assume. What are we radicalizing?
The high H, the CH2.
How would we show that? At bare minimum, what should we write?
C2.
So how are we going to show what happens? How are we going to show the bond breaking? I would say you have to at least write 1 of the hydrogens, don't you?
Yeah.
So maybe like CH, and then you could put C2H5, and then put 1 of them off to the side. You could do that. Or you could just like fully display, or you could do structural where you would stand out. No, but it's C2H6.
Oh, right.
Right? It's that. If it's less confusing, you may want to display everything out, right? but you could just expand one hydrogen because you're showing what's actually happening. What's the bond that's breaking? The bond that's breaking is one of the bonds between a hydrogen and a
Carbon.
carbon. So far, so good? How will bromine radicalize this hydrogen? It will just, basically cause it to leave. Hydrogen's like, okay, bye, I'm leaving you, ethane. Bye. I'm leaving for bromine. Bromine's more attractive.
No, that's good.
Like, right? That's what happens. That's what happens, no? So what do we get? HBr, sure. And then C2H5, that is like been radicalized, right? So you write the little dot there to show that this is a free radical now. All right, now what's step 3?
You have to take the second BR and put add it to the C2H5.
Termination. Remember, in termination, 2 free radicals meet and form a regular covalent bond and terminate the free radical. No more propagations, no more craziness going on, no more danger once the termination has occurred. What? Until a new step of initiation has begun. Are we okay so far? So, what would get together to make this product out of what we have? How are we going to get this product? We've already got the HBr. We got that. How do we get this product? What's coming together for the termination?
The C, H, and the BR.
A C2H5
BR.
and a Br. And those two are just going to make a regular covalent bond with each other
C2H5 BR.
and make C2H5Br. And you've got your other product, right? Now, before I continue, are there any other products that could happen besides these two?
Yes. The BR could just keep taking.
Right. The Br could just keep taking hydrogens. Because remember, there's not just 2 of these, there's millions. So it could just keep taking hydrogens over and over and over and over.
C2BR5.
Yeah, C2Br6, it could go to. What about this one? Could a C2H5 meet up with another C2H5
Maybe.
if more than one of these have been formed? And could that be a different termination, like a byproduct? Sure. You could get butane. Byproduct. Just bringing it up, because that's how the Cambridge questions can be if they want to get you on a paper 1, sometimes a paper 2. They could be like, what other products could you make? What other terminations could you have? Any different combination. So we're going to start looking at Cambridge questions. And believe it or not, this lesson is not too long. You will have time to work on classwork in class today, most likely. Yeah, most likely. Guess I should have put more in this lesson. I think it's a soft start, but remember, coming soon. All right, here we go. Pay careful attention to the question. Since we are going slow, I expect you all to do quite well on Friday. Free radical substitution reaction between methane and chlorine involves initiation, propagation, and termination stages. Which row is correct? First of all, in the initiation stage, is it heterolytic or homolytic fission? Homolytic. So we know it's either got to be C or D. Which radical is produced in a propagation stage?
The H goes with the halogen.
Right. H will not be made as a free radical as itself. So it is B. That's a paper 1. All right. This is a check of 12 from the textbook. I don't love this question. I probably should have taken it out. They're telling you to do a homolytic fission. Typically, this would actually do heterolytic, which is why I said I don't love this question from the textbook. But because you are instructed to show a homolytic fission, what would you do? How do we show this?
2H here.
Nope. Fission mean what? Break. Fission mean break. Right? Homo mean one goes to each. So do we do half arrows or
Half
full
arrow.
arrows? Half arrows. one to each. So what are our products?
H with a big CO.
Perfect. We'll do some practice questions before I give you them. Make sure you're on the right track. After we do the ones from Cambridge. To prep you a little bit for Friday. All right, let's take a look at this one. This is paper 2. Dichloromethane is widely used as an organic solvent. Dichloromethane can be prepared by reacting CH3Cl and Cl2 at room temperature. The reaction proceeds via several steps, as is shown. What is the name of the mechanism? This is a very common question. Free radical substitution. So the name of the mechanism is literally the name of the main type of reaction. Free radical substitution. If you can state that, guess what? That's a verb. Yes. They're going to ask about it. That's why they call it final step. I think they're going to ask what's that called, if I recall. They always leave off stuff. If they leave off something, that means they're probably asking about it. Like this is just the product. That means they want this. What is the essential condition? You can memorize, and I told you, you're going to have to memorize conditions. The condition here is UV light. So either in the sun or you would get like a little light. You may or may not remember, there's something called the Fairchild Challenge. And a couple years ago, Miss G was doing it where they had like the NASA plants. Do you remember? They showed them to UV light so they would grow. That's what they mean by having it in a lab. Continue? We're good? Oh, this is a fun one. Give the electron configuration of Cl dot. What is that? Isn't that just regular chlorine? It is just regular chlorine. Isn't it? No. It is. It's chlorine that has not gained an electron. It is radicalized chlorine, but it is standard chlorine, just not in its standard state. So how would we write the electron configuration?
1s2, 2s2, 2p6, 3s2, 3p5.
Perfect. And that's a mark. Mark unlocked.
Identify the products.
Of the step labeled propagation 2.
Wouldn't it be
So-
Cl plus H2, Cl2?
Yes. Got it. So what happens in propagation 2? Trace what happens. You've got this free radical. Free radical, what do? They make others into free radicals. Do you agree? That's what they do in propagation. So CH2Cl approaches Cl2, which is like this. What will CH2Cl be taking to their cause? A chlorine. Do you agree? Like, hey, come with me. No, you just have to write the answer, which is this CH2Cl is taking a chlorine, right?
Yeah.
So you would get CH2Cl2. And then, no, it's not quite. What does this become
A Cl with a dot.
with a dot? Because like that lost, it, that make sense? Do you want to
Think
show
about it,
propagation 1? I can show you propagation 1. Propagation 1, this chlorine approaches CH3Cl, right? And what is chlorine stealing? They're telling me what it's stealing. Stealing a hydrogen, isn't it? Like, come with me, buddy. And so you get HCl as a product, and then the other product is CH2Cl, and that carbon's been radicalized. That's what you got there. What? This is not a radical anymore, but this one is. So it's propagating new radicals. In order for this to become stable, it has to make others unstable.
On this question, always.
It is 10% of a paper 2. You know what you're doing. Are we good with this answer for propagation 2? Not really? Yes?
Yeah.
Okay. So CH2, Cl2 plus
It's
Cl.
field
That. Now, 5. What is the type of reaction in the final step? We have 2 free radicals. They meet and they connect. That's called termination. What we call termination. So is Cambridge asking you to memorize mechanisms? Now, an interesting question. Suggest the identity of another organic molecule that could be the product of the reaction of CH3Cl and Cl2 in the same conditions. Are there any other products you could make besides what they have told you here? Anyone make a suggestion?
CHCl3.
That's the first one they give, actually. And that's basically just doing another chlorine for another hydrogen, that it can happen over and over again. So, CH, Cl3, what are other options? You could literally just do CCl4. And they also said that, like, you could take this, and 2 of these could meet up. 2 of these could meet up. And you could do CH2Cl2 with the parentheses, like this. They said that this was a thing. Like that, which is basically just this and this, right? Like that. Like those 2 meet up. The CH2Cl and the CH2Cl meet up. And you could have written that as C2H4Cl2, like that. You could have written it, right? That's how it is in the mark scheme, but you could have written it like this.
There'll be nothing else, right? There's going to be the only part. CHCl.
They just said to suggest one.
Okay.
So any of these would work as a potential answer. You don't have to give all 3. Are we good with that? This or that or that. All right, so let's do some practice reactions before we go to some homework for you, because we do have some extra time. Because mechanisms, it will stick. I said do very well on your first couple of quizzes, right? Because it's going to build. And if you're paying attention, actually organic is not necessarily as difficult as some of the things we learn otherwise in the class. The problem with organic is not the difficulty of the subject matter, but the amount of information that you're going to need to retain. So it's important to practice. Let's see if we can do some reactions. Predict the product. CH3 plus Br2 UV light. What do you get? This is how your quiz is going to be. Yeah?
So it would be
What happens here? If I just am doing the major type of reaction, reactants to product, what do we do? What's the type of reaction?
Free radical substitution.
And if I'm just giving the product, what's the only thing I need to know? 1 hydrogen swaps with a
Oh,
bromine. So what are your products?
CH2Br plus BHBr.
so it doesn't matter how long the chain is, only one H will switch out.
Right. And so that means there can be multiple answers that are correct. Let's take a look at something more
Like
complicated.
the structure can be different. So will they ask us, just like how they did with the structural isomers, different structures that could be?
Starting next class, we're going to have a major and minor product. So yes. Make 1 major product out of this. Make 1 product. Well, 2 products. One would be the byproduct, one would be the organic product. Predict the products. Assuming that the propagation only happens once, predict the products. What would you do here?
The same thing you did before.
Are there variants of answers you could get?
No.
What are the variants?
You get put on C on the line.
What are your variants of potentials?
You can put the CL on it.
So pick one. Pick one. Where do we want to put our chlorine first?
The second one.
You want to put it here?
Yeah, right there.
Okay.
You could also put it up the top, right?
Where else could I put it?
Did you put it on?
Anywhere you can swap with a hydrogen is the answer to that question. So, yeah. Where else could I put it? Wouldn't that be the same?
On the third one, no.
That wouldn't be an isomer, would it, if it was here? Because it's that one, right?
Yeah.
So you could put it here. Or any others?
Put it on the end.
Is this a symmetrical molecule? So you can put one here, put one there,
Yeah.
and you put one there. Or isomers are still here.
I don't like that.
Or here. Or like that, right? Good.
And the other tail end?
6 variants. This one here, you mean?
Yeah.
It's the same as that one. Because the methyl groups are the same. So 1, 2, 3, 4, 5, 6 variants of possibilities. That's crazy, right? Could they do something like that to you on a paper 1 and ask you how many different options you could have?
Yes.
That'll work next class is coming. All right, so I think that's enough time. You're gonna do 2 things for your homework today. The first thing, I'm gonna give you a cardstock, and you're each gonna draw your own mechanism. So first, draw the fully labeled mechanism for the reaction of propane with chlorine. Before you do this, I want to tell you one more thing. Where are the marks in this mechanism, by the way, traditionally? Typically, where are the marks? I already erased it. Usually there's 1 mark for naming all 3 steps. Typically, there's 1 mark for correctly showing each of the steps. So that means that how many marks could that be? 1 mark for the initiation, 1 mark for the propagation, and 1 mark for the termination. And sometimes there's a mark for a byproduct. Sometimes there's a mark for just naming the mechanism like you saw here. So when free radical shows up, it could be somewhere between 3 to 5 or even 6 marks. That's a lot of marks. So every topic in organic chemistry is one that needs to be studied well. This is our first one. And so what we learned today, alkanes are boring. They don't do much. You can burn them. And you can do free radical substitutions. You can radicalize them. And so,
Wait, but we didn't do hetero ones, right?
no, that's next class. Because alkanes don't do that. So it's just the other type of bond breaking. Alkanes, carbons and hydrocarbons with just single bonds don't do that. All right, so I'm going to give you a cardstock. You're going to draw the fully labeled mechanism of this as the first part of your homework, and then I'm going to be passing out the second part of your homework shortly. So first I'm giving you cardstocks. This is going to be attached with your homework. Here you go. Drop the pot, please. This is for the mechanism. Fully label the mechanism first, and then you get the regular. You're going to attach this to That way you can make sure if you end up making a mistake, you can fix it. This is for
Yeah.
the mechanism.
I mean,
Everyone needs a copy of the mechanism with their homework.
like,
There you go. You're drawing up the mechanism. Sorry, Denver. One product though. Well, just the like one organic product and then the byproduct.
No harm.
It has two options of what it
How
can be.
brittle my arm is.
No harm intended.
I fell on the ground.
Yeah.
My arm is gonna rotate.
Like I did for
Don't break it.
or like I did for I did one here. Like a fully loaded when I was there. I showed one fully loaded.
Your left hand.
There you go.
Not purposely losing.
All right. First part of the homework is what I wrote there. You must finish that before class, and I'll stamp it when you're done. This is the second part. So David, as well, do the mechanism for the first part. You gotta do that part in class. So everybody has to finish the mechanism in class, and then you can get started with the homework. Next class, you're starting the flashcards.
Yeah, do this in house, so.
Here you go. There you go. For reaction propane with chlorine. Our last unit. Unit 7 is equilibrium and like acids and bases. Yeah. Then there's like a month of review for your first paper. So you can see from the schedule, this unit's really tight. We gotta be on pace. There's a specific list of things that have to get done each day.
I can't spell.
And you're gonna practice continually by starting to do the flashcards and practice.
We're finished 3, right?
Like I said, you just make a big pile, and then you move over the pile that you got. The pile. I don't know. Ask the students last year.
April had like, the binder was like over.
So it's propane with chlorine. I want a fully labeled mechanism. Practice with your curly arrows too.
I would have told you.
Your half curly arrows.
Okay, I get it.
When you're done, show it to me and I'll let you know if it's good. Propane with chlorine. Yes. Sure. When you're done, you can start working on the regular homework. Yes. In the fridge.
Yeah, because it looks like my best friend dropped me off something.
Okay, I'll write something for you.
She can't call me down because she's not on the paper.
I'm just going to put main office. And today is the 5th. Come back and continue working on the mechanism. Okay, you're good.